Hi, and welcome to Chapter 7. In Chapter 7, we're going to start manipulating strings and characters. Let's get started. First thing to understand with strings and characters is the problems that come in when you're using them. Characters are primitive types, so you can do manipulation on a character, you can do equals, and you can do greater than or less than on a character, but you cannot compare strings. So if you have a name, Joe, and you want to equal it or compare it to the text, Joe, you can't just set them equal to each other because they're objects. They're not actual strings. They're not actual collections of letters. They're not primitive types. They're actually objects. So when you compare strings, when you say name equals another name, you're actually comparing the address of the data, which isn't going to be the same if you have two different variables. So what we do is we have a couple of solutions that we can use in Java that are going to help you. We have a character class to be able to check individual characters. We have a string class, and we have the StringBuilder and StringBuffer objects that you can use. So let's look into a little bit more about what you can do with each of these options. So first, the character class. Characters are primitive types, which means you can do manipulation on a singular character. Other things you can do with it using the character class is to use some of the static methods that are available. Remember, you don't have to have an instance of an object to be able to use the static methods. So in this case, we're going to have a couple of different methods that we're going to use. We have some is methods that return booleans, and we have some to methods that are going to manipulate and return a character object. So we have an is uppercase, is lowercase, is digit, is letter or digit, or is white space. These are all of our is methods. And these methods are going to return a boolean, yes or no, true or false, remember? So when I want to say character is digit, I can pass it a singular character and it will return a boolean letting me know if it's a digit, which means I can use this inside of a conditional in an if statement or something along those lines. So any of the is methods are going to return booleans, true or false. So is digit, is uppercase. So I can look at a character, individual character, and find out whether or not it's uppercase or lowercase. I can also tell whether or not it's a digit or a letter or a digit, as opposed to white space, as opposed to special characters. This is useful when you validate your data to make sure that your user is doing what they're supposed to do. Your to methods, to uppercase and to lowercase, are useful if you need to manipulate something and make sure it's an uppercase. If you pass a to uppercase method a capital A, it will return a capital A. But if you pass a to uppercase a lowercase a, it will return a capital A as well, which means you can use this to make sure that your letters are the same case. This is really useful in cases where you want to do a is yes or no, a Y or an N, but sometimes the user puts capital Y and sometimes they put a lowercase y and you're not quite sure what to do. You really don't want to have to check both cases. Just throw a quick to uppercase in there and it'll only give you the uppercase value. So we like these character class methods that we can use to manipulate individual letters, individual characters. When I said you cannot directly compare strings, you can't, but that doesn't mean that we can't use methods on those to do those comparisons. So we have things called literal strings. They're anonymous. They have no name associated. It's when you actually type quotes and put a string in it, as opposed to string x equals quote hello world. Now I can use string x, which is a named variable, as opposed to a literal. So a string variable named is the ones where you would say either new string or the shortcut, which is just setting it equal to a specific string. Most people don't think of a string as an object, so they don't tend to use the new, which is just declaring a new string object, the same way you would a new student or a new employee. You could do a new string. Same kind of thing. It's a class object. You could use it that way. Strings objects, string objects, are technically immutable. Mutable, mutate, means that they can be changed. Immutable means they cannot be changed. So strings are technically immutable. That doesn't mean that you can't reset the value to a new value. It just means the string itself is immutable. You cannot manually go in and modify individual locations in the string. You have to use some of the string methods that we're about to give you. There is a mutable or a changeable version called a StringBuilder that we'll talk about towards the end of this lesson. On your string, so I could do a string with quotes, or I could have a string variable, and I can use a method called equals. Equals is designed to compare between two strings. So rather than doing name equal other name, I would use name dot equals and then add another name in parentheses. This allows you to do what we call a lexicographical comparison. It doesn't work if obviously the spelling is different or the case is different, because a capital A is technically different than a lowercase a. So it's not going to work if you have a capital A and a lowercase a and you want to compare them. They're not the same number, or the same letter. They're not the same string. Equals will always return a Boolean. It'll return true or false. Does it equal? However, sometimes you want to know what direction does it equal. Is it bigger or smaller? If we wanted to compare Roger to Robert, if we wanted to compare AB to AD, you can use a compare to method that is going to provide an integer comparison. If those two strings are exactly identical, it will turn 0. They are identical. There is no difference between them. Otherwise, it will return either a negative or a positive number, depending on what the difference is between the two. If you were to compare the two between AB and AD, you would get a -2, because the difference between the D and the B is 2 spaces. So B is 2 spaces different than D, and therefore you would get a -2. Same direction if we went with Roger and Robert, the R and the O are the same, but the G and the B is a +5 difference from a B to a G. So we can do compare to compare strings and be able to find the integer value of either positive or negative to find out if one is larger than the other. We use this a lot in alphabetical searching. So if we want to alphabetize or sort our strings, we would use the compare to method to be able to figure out which side to sort with. We'll get into sorting later, I promise. Sometimes you have empty strings. This references a memory address that has no data in it. So it still has a memory address, it's still stored in memory. There's a location, it's just empty. It has nothing in it. There is no actual values inside of it, but it is still pointing to that address. String equals null has no memory address. Null does not refer to a memory address. Those are two different values. By default, string x with no value is null. So string x equals null and string x do exactly the same thing. It sets it to default of null. There is no memory address to it. However, as soon as you set string x equal to an empty string, which is open and close quote with nothing in the space, nothing in the middle, not even a space between them, now it refers to a specific memory address that has no value in it. So difference between empty and null, they actually mean two different things. And you want to think about that when you're going to assign your string. Do you want it to start out with an empty string, or do you want it to have no memory addressed? So we've already shown you the equals string method. Let's talk about a couple of the other ones. String has a length method. It is a method. It has parentheses just the way any other method does. So string.length, so x.length, is going to return the length of the string. In the example here, where x is equal to hello, it's going to return 5. There are 5 characters. Index of takes a character in single quotes, a single character, and returns where does that character exist in the string. Remember, we're 0-based. Everything's 0-based. So the letter E occurs at the second position, which is at position 1, 0, 1. Remember, we're 0-based. If you use index of on a letter that doesn't exist, it will return -1. This is useful when you're going to want to do something that says, does this letter exist? And you want to handle, it doesn't. So returning -1 is a comparison that you can do later to find out if the index of the letter exists. We can return the character at a specific index. So index of returns what index they're at. Character at takes an index and returns the letter at that index. So if I want to pull an individual letter out at the index of 4, I can get the letter O. So we can go through and say what's at index 0, what's at index 1, what's at index 2 by using the character at method. Again, remember 0-based, always 0-based. We can use a starts with, and there's also an ends with. starts with to determine whether or not the string starts with the string that you have selected. It doesn't have to be the whole thing, so it's not an equals, but it does just the first couple of letters. So if we want to do a starts with. We also have the option of doing replacements. We can replace all of the L's with Z's, and it will replace all instances of the first value with the second value that's given. So these are some different string methods. Once we have those strings, we can use wrapper methods to convert from a string to a number. Again, it's up in the green up here. These are called wrapper methods. And these methods are off of the classes for what you're trying to convert them into. So an integer dot parse int, a double dot parse int or parse double, float dot parse float. So this is going to take a string value and try to parse it into a number. It's going to try, and it's going to do pretty well with a parse unless you give it something that it's really confused at. So parse is a good way to convert with your strings and your numbers rather than having to use direct casting. Parse handles it a little nicer. The last thing you can do with string methods is you can convert any primitive type to a string by concatenating it with a string. So if we have a primitive type like the number 34 and we want to concatenate that with the word hello, we can just turn 34 into a string that is concatenated. It will immediately convert the primitive type into a string. This works only with primitive types. With object types, usually you will have a toString method on it. And when you build your classes, you're going to do the same thing. You're going to be building toString methods so that you can do the same kind of thing. I can have an employee.toString, and this is what will come back every time I try to print the employee or try to use it as a string. We're going to take a few minutes to go look at some code, see how we can use some of those methods that we just talked about in real life. We're going to go ahead and walk through the UDoIt on page 348. So the first thing I need to do is to create my repair name class. So I'm going to select my chapter 7 and do repair name.java. So I can make my first class, and then I will go ahead and do my main, public static void main. Okay. Now, this method that we're going to be creating is going to use the swing operators just to make things look prettier. Let me go ahead and add to my source path so that will make me happy. So we're going to go ahead and use the swing just to make it with a GUI because we haven't done that for a while. It's always good to do that. So first thing I'm going to do is create a couple of string variables, because we're going to do some string manipulation here. And we're going to make a name, and we're going to make save original name as our two string variables. I'm going to make an int as our string length. And I'm going to make an int that's an I, because I like to have my iterator character that's a C. And then we're going to set our name equal to whatever the user ends up putting in there. So we're going to do our name equals, and we're going to use our J option pane, show input dialog null, and our message in this case is going to be please enter your first and last name. Don't forget my semicolon. Okay. So we're going to store the user's name in name. We're also going to save it in save original name so that we can reference back to it later. Save original name, it's going to equal name. Now we can manipulate name, and it's okay because we have the original name saved. So we're going to figure out what our string length is, and that is going to be our name.length. Don't forget, length is a method, so it takes open and close parentheses. Okay, let's do a quick little for loop to be able to concatenate a uppercase letter for our name so we can make it capitalized nicely. So we're going to do a for I equals 0, I is less than string length, because now we know what that is, I++. Okay, so we're going to walk through our string, figure out what each of the things are going to be in this position. So first we're going to get, what is the character at, name character at index I. So we'll start with the 0 index and then move our way through. If I equals 0, so if we are at the 0 position, I want to make my name capitalize that letter. So I'm going to set C equal to our character method called toUpperCase, and I'm going to pass C in. So what this is going to do is if I type in my name of Cheryl and I keep it all lowercase, it's going to say, what's that first letter? The first letter is a C. Let's go ahead and uppercase the C. So now C is equal to an uppercase C. A little ironic that we're using C. I could put CH to make it a little clearer. And then next we are going to change the value that is inside our name variable to be our now uppercase first letter and our name substring. In this case, we're going to substring because we want to start at 1 and go to the length. What this is going to do is get HERYL as the name substring and then the capital C. So we're going to capitalize our first letter of our name. After the first character of the name is converted, the program looks through the rest of the name, testing for spaces, and then capitalizing any letter that is not a space, or that is a first letter after a space. So I equals 0 is going to be that first case. So let's go ahead and put a comment here. Capitalize it, the first letter. Okay, now we want to run down in our else, and if the name character at I is a space, we got to put a space in there. There we go. So if it's a space, sorry, I did my wrong direction. Then, I'm sorry, I didn't get character at. Character at. There it goes. Then we are going to increment our I and capitalize the next letter. So we're going to do it ++I to increment our I. So I will now be one more. Then we're going to set our C equal to our character to uppercase of whatever, I'm sorry. We're going to set our C equal to our character. So we are going to do our name.character at the new I that we've just created. Then we are going to set C equal to character to uppercase of C and set our name equal to the name substring of everything from 0 up until I. So we get the Cheryl space. Then we're going to concatenate our uppercase letter. Then we're going to concatenate the rest of the name. Substring. And we're going to go from I+1 to the rest of our string. So string length. Okay. What this is going to do, make sure that you understand that, is that it is going to walk through, if I put John Paul Doe, it will capitalize the J for John, walk along until it finds the space before the middle name. When it finds the space, it looks at the P for Paul. It will go ahead and capitalize the P, add that on there, then keep walking until it finds the space before Doe, capitalize the D for Doe, and go to the end. It will keep doing this until it gets to the end of your string. Okay. Finally, when we are finished with our loop, so we've gone through our entire loop, checked all of it, we are going to print out our JOption pane dot show message dialog. And in this case, we're going to do a string that is going to say original name was save original name plus, and then we will put a new line and say repaired name is, and we will put our new name. And because we updated our name each time, our new name is going to be what our answer is, or what the updated version is. So let's go ahead and run that. Okay. So you can see it popped up the little dialogue. Please enter your first and last name. I'm going to do, let's do John Paul Jones. And you can see the original name was John Paul Jones, and the repaired name is capital J, capital P, capital J. So we were able to update each of those letters and be able to manipulate our string that way. The next part of this is going to be another file that we're going to do called number input. Now, this is going to be similar in the fact that we're going to use our dialog as well. We're going to go ahead and do our main. And we're going to do a couple of variables. So string, input string, int, input number, and result. Okay, a couple of variables hanging out up there. We're also going to add a final int called factor that is going to be 10. Remember, we have to set it because it is a constant. Okay, our input string is going to equal our J option pane dot show input dialog, and we're going to say enter a number. Okay, our input string is now going to be the number, but we need to cast that into an integer because we want to do some math upon it. So we are going to set our input number. Remember, we had an input string and an input number. Our input number is going to be integer dot parse int, and then it'll take our input string. Remember, when you have a string and you need to cast it into an integer, it's good to parse it because it'll be able to handle it if it fails. We're going to set our result equal to our input number times our factor. Whoops, I better make that all caps. There we go. And we are going to print our result. So I'm going to say J option pane dot show message dialog. And we're going to say our input number plus multiply by our factor equals our result. So now when I run this one, it will go ahead and say enter a number. I can say 15, and it will say 15 times 10 equals 150. So it's able to take that integer and do mathematics on it, even though it started as a string, because we were able to parse that number. So StringBuilder and StringBuffer are two other objects that we can use. As I said at the beginning, strings are immutable. Since strings are immutable, you cannot change them. You just have to keep reassigning them to a new value. StringBuilder and StringBuffer if you're running multiple threads, but that's kind of a secondary thing. StringBuilder is more efficient because it initializes with some extra space to allow for modification. That will allow you to modify the string without having to reassign it. StringBuilder uses some methods called append, insert, set character at, and character at to be able to manipulate and move things around. If you know that your string builder is going to start with a blank string and build up to 300 characters, you can assign it as a new string builder with the initialized 300 characters in its constructor. So if you expect your string to be big, go ahead and initialize it as a larger number. That way it doesn't have to keep modifying it. You're going to set it to that and then be able to append or insert as you need to. And you wouldn't be able to do this with just a regular basic string. So let's look at some StringBuilder stuff. For our final UDoIt, we're going to go ahead and make a StringBuilder and play around with that. So StringBuilder methods.java. All right, we are going to make our public static void main. And inside here, we're going to create a new StringBuilder. StringBuilder SB equals new StringBuilder. And inside, I'm going to say singing. You're going to understand why in a minute, because we're going to manipulate that and play around with it. So we have a new StringBuilder. It might help if I made it SB instead of SP, although that really doesn't matter. That's just my notation. All right. So first thing we're going to do is print that out. System out, and we're going to just print our StringBuilder. Cool. Now let's start playing around with it. So we're going to do our StringBuilder append. And we're going to say in the dead of let's print it out now. System SB. And let's insert at the front. So we're going to do sb.insert at the front, so at 0, the word black. Okay. Next, we're going to print that out just so that we can see what's going on. Next, we're going to insert at position 5 the word bird. Now, where do you think position 5 is going to be? And we're going to throw a space after the word bird because we're going to need that. So we can see what that's going to look like. Finally, we are going to append the word night at the end. And finally, we'll print it one more time. So, printing this, you'll see we started with singing. We did singing in the dead of. Then we added the word black, but we didn't put a space here because then we added the word bird at the end of black to say blackbird with its space. And then finally, we added the word night at the end. So we were able to manipulate the string back and forth by doing appends and inserts in the different positions that we wanted to use. Hopefully this helped you to understand a little bit more about how strings are manipulated in Java. Couple of things to remember. Don't compare your strings with equal equal. You can use the dot equals method, but don't use equal equal because you'll be comparing memory addresses. Starts with and ends with all replace are case sensitive. So remember, starts with, you have to have the casing correctly for it to work right. The new operator, if you're going to use a new string builder, you could even use the new operator if you're going to create a new string. That's fine. Funny thing about StringBuilder and StringBuffer, only use them if you have a good reason. If you don't intend to modify your string, don't waste the space on a string builder. Just define a regular string and it's fine. Most of the time, you're not going to be manipulating strings. You're going to define a string and you're going to use it exactly as it is and it doesn't need to be modified. Use a regular string in that situation. Don't change it to use a string builder just because you can. Use a string builder when you logically need to manipulate your string. Hopefully this chapter gave you a little bit more information about strings and how to manipulate them. Come back next time for chapter 8. Have a great week.